Hi, my name is Sungjae Cho from KAIST, South Korea. Now I am going to present a show and tell demonstration titled Learning to Transfer Multi-Speaker Emotional Prosody to a Neutral Speaker. I'm going to demonstrate emotional speaker audios spoken in one speaker's voice without any emotional speech spoken by the neutral speaker. In this presentation, I will show two demos. In the first demo, multi-speaker emotional t-test demo, you can listen some speech audios of two speakers and 5 emotions. Our t-test system can speak with 5 emotions in the two speakers' voices, which has been learned from audios of 5 emotions spoken by the two speakers. In the second demo, you will listen some speech audios of one neutral speaker with respect to the 5 emotions. Our TT system can speak with 5 emotions in the one neutral speaker's voice. The emotional prosody of the neutral speaker has been transferred from emotional audios spoken by the other two speakers. Our t-test system is given only neutral audios of the neutral speaker. Before the two demos, I will describe what data, model, and training settings are used to make our t-test system. So before starting this presentation, why is transferring emotional prosody valuable? Acquiring emotional speech is expensive because it requires professional acting ability. So it will be economical and beneficial to transfer emotional prosody to neutral voices. Let's see what data was used to train our model. We used two data sets, LG Speech 1.1 and InMovieDB. The LG Speech dataset is a t-test dataset from audio data spoken by a single female speaker. This dataset has about 13,000 audio clips that totally have about 24-hour records. The InMovieDB dataset is a t-test dataset that contains emotional voices of 5 emotions containing neutral emotion, spoken by 4 speakers. We used only 2 female speakers clips for better prosody transfer. Each speaker's audios are totally about 1 hour and 45 minutes. The total length of audios of each emotion for each speaker varies from about 15 minutes to about 15 minutes. Their length is imbalanced concerning emotions. Compared with the LJ speech dataset, InMovieDB is very small. Our model follows the model proposed by Jiang's work, titled Learning to Speak Fluently in a Foreign Language, which appeared in Interspeech 2019. We added module 1 and emotion embedding module and used the WaveGlow vocoder instead of wave ordinance vocoder. Other than these modules, all modules in this architecture are same as the architecture of the previous work. Module 1 and Module 2 perform adversarial training to resist encoder outputs from encoding emotion and speaker representations. These two modules encourage encoded character sequence to be disentangled from emotion and speaker identities. The two modules help the decoder get speaker and emotion control signal only from speaker and emotion embeddings. According to our experiments, it was possible to recognize speaker and emotion from almost encoder outputs because sentences spoken by emotional speakers and those by a neutral speaker were from different text sources. Module 3 was originally used in the previous work for better transferring speaker voice identities and making speech more natural. Module 3 acts like the encoder part of a variational autoencoder. This module encodes latent factors such as prosody or noise, which are not well explained by conditioning inputs. The conditioning inputs are the encoded character sequence, speaker embedding, and emotion embedding. When our model generates speech, we feed three conditioning inputs: a sentence, speaker, and emotion identities. Additionally, the residual encoding is set to be zeros. This zero setting contributes to averaging out latent factors that are not related to the three conditioning inputs. Training settings. We used pre-trained WaveGlow, namely we did not train WaveGlow. The pre-trained weights are provided in the NVIDIA GitHub page. Our model was initialized with Tacotron 2 weights pre-trained by LJ Speech 1.1. You can find these pre-trained weights in the NVIDIA GitHub page. Upsampling was utilized to make samples per batch equally distributed with respect to speaker emotion pairs. Upsampling is crucial to solve data imbalance problems. We followed the training settings of the previous work, such as batch size, learning rate scheduling, losses to minimize, and so on. Additionally, we set beta, the KL divergence rate, according to the cyclical annealing schedule. In the first demo, we are demonstrating multi-speaker emotional TTS. Through our system, you can synthesize 5 emotional voices across 2 female speakers, B and J. In the training data, we had neutral and emotional speech audios of the 2 speakers. This is a major difference with the second demo. I'm going to play 3 examples for each emotion speaker pair. What we want you to pay attention to is how different given audios are across emotions and speakers. First, you will listen to a neutral voice, and then an emotional voice will be presented. The first emotion to demonstrate is amusement.
I'm amused. I'm really amused. I'm amused. I'm really amused.
I'm amused. I'm really amused.
I'm amused. I'm really amused. What is that? What is that?
What is that? What is that?
I have first seen this in my life. I have first seen this in my life.
I have first seen this in my life.
I have first seen this in my life.
The next emotion to demonstrate is anger.
I'm angry. I'm really angry. I'm angry. I'm really angry.
I'm angry. I'm really angry. I'm angry. I'm really angry.
It makes me so upset. It makes me so upset.
It makes me so upset.
It makes me so upset. What is this stupid thing? What is this stupid thing?
What is this stupid thing?
What is this stupid thing?
The next emotion to demonstrate is disgust.
I'm disgusted. I'm really disgusted. I'm disgusted. I'm really disgusted.
I'm disgusted. I'm really disgusted.
I'm disgusted. I'm really disgusted. It smells so disgusting. It smells so disgusting.
It smells so disgusting.
It smells so disgusting. It feels really strange. It feels really strange.
It feels really strange.
It feels really strange.
The last emotion to demonstrate is sleepiness.
I'm sleepy. I'm really sleepy. I'm sleepy. I'm really sleepy.
I'm sleepy. I'm really sleepy. I'm sleepy. I'm really sleepy.
It is too late. It is time to go to bed. It is too late. It is time to go to bed.
It is too late. It is time to go to bed. It is too late. It is time to go to bed.
I didn't remember that scene. It was so bored. I didn't remember that scene. It was so bored.
I didn't remember that scene. It was so bored. I didn't remember that scene. It was so bored.
In the second demo, we are demonstrating emotional TTS spoken by a neutral speaker. Through our system, you can synthesize 5 emotional voices of a female speaker, L. In the training data, there were only neutral speech audios of the L speaker. Our system can generate emotional speech of the L speaker because emotional prosody has been transferred from the other two speakers' emotional prosody by jointly learning their emotional speech. Let's listen to emotional voices of the L speaker. The first emotion to demonstrate is amusement.
I'm amused. I'm really amused. I am amused. I'm really amused. What is that? What is that? I have first seen this in my life. I have first seen this in my life.
The next emotion to demonstrate is anger.
I'm angry. I'm really angry. I'm angry. I'm really angry. It makes me so upset. It makes me so upset. What is this stupid thing? What is this stupid thing?
The next emotion to demonstrate is disgust.
I'm disgusted. I'm really disgusted. I am disgusted. I'm really disgusted. It smells so disgusting. It smells so disgusting. It feels really strange. It feels really strange.
The next emotion to demonstrate is sleepiness.
I'm sleepy. I'm really sleepy. I'm sleepy. I'm really sleepy. It is too late. It is time to go to bed. It is too late. It is time to go to bed. I didn't remember that scene. It was so bored. I didn't remember that scene. It was so bored.
This is the end of our demo presentation. Thank you for listening.